Hello everyone, my name is Raina DeJute and welcome to my Module 7 Technical Demonstration and Overview. In this video I'm going to walk through a complete software project called the Rocket Elevators Admin Portal. This is a great example of a real-world application that manages employee data for a company. We're going to break down every layer of how this works from the moment you type in your password to how your data gets stored and how everything comes back to the screen. So let's jump in. So first, let's talk about the big picture. What problem does this application solve? Imagine you're a company like Rocket Elevators. You have sales agents working in different regions. You need to keep track of who they are, where they work, how well they're performing, what fees they charge, and how much they're selling. You could use a spreadsheet, but spreadsheets get messy really fast and they're hard to keep up with, so instead we built a dedicated admin tool. The Rocket Elevators Admin Portal lets administrators log in securely with their email and password, see a list of agents across the company, create new agents when somebody joins, edit an agent's information if something changes, delete an agent if they leave, filter agents by regions, and sort agents alphabetically. It seems simple, but building simple actually requires a lot of engineering underneath. So in this specific project, we are using a 3-layer architecture. So thinking of it like a restaurant, the first layer is the customer front end. The React is running in the browser. It's what the user sees and clicks on. It handles showing the agent list, displaying forms, managing buttons, and menus. Layer 2 is the kitchen, which is the backend. This is a Node.js and Express server running on a different computer. When the front end needs something, it sends a request over the internet. The backend processes that request, validates data, checks permissions, and talks to the database. Then we have layer 3, which is the storage room or the database. This is our MongoDB, a database that stores all of the actual agent and user information. When the backend needs to save or retrieve data, it talks to MongoDB. Here's the important part. These 3 layers talk to each other through APIs and HTTP requests. They don't know or care what technology the other layer is using. The front end doesn't care if the back end is written in Node.js or Python. It just sends and receives data in JSON format. And why is this architecture important? It is called, you guessed it, separation of concerns. Each layer has one job. The front end focuses on being pretty and responsive. The backend focuses on logic and security, and the database focuses on storing data reliably. If you need to swap out one layer, say migrate to a different database, you can do it without having to break the others. So let's go step by step and trace a concrete example to show how all of these layers work together. So as you can see, this is our login page. The first thing that happens is a user will type in their credentials, which is the email and the password in these fields. When the user hits the login button, React collects the data and sends an HTTP request to the login handler. Then the login handler looks up the user in MongoDB and checks the password. If valid, the backend generates a JWT token and sends it back. As you can see, our credentials were valid, and so now our front end can show the admin dashboard because the user has been authenticated. Okay, so let's zoom into the front end. In this project, we are using React, which is a JavaScript library for building user interfaces. If you've never used React, which I didn't before this, here's the key concept. The React breaks the UI into components. So think of components like a Lego brick. Each button is a component. Every one of these buttons, being able to scroll, this sidebar right here, all of these are components. The entire app is just a collection of components stacked together. Each component has its own code and its own styling. Why is this useful? Because components are reusable. If you build a button component one time, you can use it everywhere, and components have a life cycle. They can fetch data when they load, update when something changes, and clean up when they're destroyed. And as you just saw, when someone logs in, they should see the agent dashboard, which is what comes up right here, not the login page again. That's where the routing comes in. So in this project, we are using a React router. It's like a traffic control for the front end. When the app starts, React router checks the URL. If it's -login, it shows the login page. If it's just a dash, it shows the agent list. If it's -edit-123, it'll show the edit form for agent 123. But this is the clever part. We have something that's called a protected route. This is a component that wraps the other routes and says, only show this page if the user is logged in. Here's the logic. If the user has a valid token in local storage, it shows them the protected page, which in this case is the agent dashboard. Otherwise, it'll redirect them to the login page. This happens before the page even renders, so if someone tries to hack the URL and go directly to -edit-123 without logging in trying to bypass, they'll get bounced back to the -login, which is the login page where they can enter their credentials and be authenticated. So React components need to remember things. When you fetch a list of agents from the server, where does that list live? In state. React state is like a component's memory. This is a simple pattern that you'll see throughout this app, and it's this pattern right here, this constant agent set agents, loading set loading and error set error. So each use state creates a variable that React watches. When that variable changes, React automatically re-renders the component. So when we fetch agents from the server and call set agents agent list, React knows the UI needs to update and it redraws the list. There are 3 variable states here, and they follow a pattern. Why all 3? Because the user needs to know what's happening. Agents is the actual data that we're displaying. Loading is the data still being fetched, show a spinner or a loading bar, and error is did something go wrong, show an error message. The pattern repeats everywhere in this app. It's not fancy, but it's robust. And then here is where things get interesting. So when a page loads, we often need to fetch the data from the server. We do this with useEffect, which is a React hook that runs the code at specific times. So this runs the code when the component first mounts. And then for this fetch agents, this empty array right here means run this only once on mount. The function we pass to useEffect runs after the component renders. So the flow is, number 1, component renders with empty state loading equals true. UI shows loading in a spinner or a loading bar or whatever the case is. useEffect runs and fetches data from the server. Data comes back. We call set agents data. React re-renders with a new data, and UI shows the agent list. This is a bit different from the traditional programming that I've done in the past modules where we load data before rendering. React renders first with empty data, then fills the data in when it arrives. This feels weird at first, but it's actually really elegant because the UI always stays responsive and it never freezes while it's waiting for data. So let's take a look at the login form and walk through that step by step. So the page renders with 2 input fields, email and password, and a login button. As the user types, React updates the email and password state variables. When the user clicks login, a function called handle login runs, and this is right here in loginpage.jsx. So we can see this constant handle login, and then we set the loading to true. We set the loading to true so that way the login button disables while the form is loading. It sends an HTTP post request to the backend with the credentials, and you can see here that we have the input validation, just making sure that the email and the password are both of these fields have values, and then right here we can see our post request. If the backend says success, then we store the JWT token in local storage. We navigate to the agent dashboard, which is this slash, and if it fails, then we go to this unauthorized page. So for instance here, if I were to take out this @ symbol and then try to hit login, it'll give us that error message. And if I hit the @ symbol and maybe take one letter out of the password and try to hit login, it takes us to this unauthorized page. Now, why do we use local storage instead of just a variable? Because variables get erased when the page refreshes. Local storage persists across browser sessions. So if a user were to log in and close the browser, they'll still be logged in when they come back. Now let's log in with the right password and take a look at the dashboard. So as you can see, it shows all of the agents in a table, but there is a little extra functionality here. We can filter by region and we can sort by name. So as you can see, we can do Z to A and A to Z. Here's the cool part. We're not making new API calls to the server when we filter. We're fetching the data once and then we do all of the filtering in the browser. Why? Because it's faster and more responsive. Users get instant feedback as they change filters, as opposed to the last module, every time we were trying to sort by a region, we were doing a get agents by region request. In this case, we use something called use memo to cache the filtered and sorted results. And all of that lives in this agent table.jsx. Notice right here at the bottom, the dependency array. So this tells React only recalculate this if one of these values changes. So if the user clicks a button that doesn't affect any of these 3 things, use memo doesn't waste time recalculating the whole thing. This is what's called performance optimization. It's not strictly necessary for a small app, but it's good practice because it scales very well. One more pattern that we have is we have a file called authservice.js. This handles all authentication related API calls. This is what is called the service layer. It's a bridge between React components and the backend. Why is this separate from everything else? Because if you called the backend directly from 20 different components and then need to change the API endpoint, you have to edit 20 different files. With this service layer, we edit one file and it's fixed everywhere. The auth service has methods like login, email, password, which makes a post request to the API/login. Then it has logout, which clears the token and the user data. Then we have this get token, which returns the stored token, and then this is authenticated, which checks if the user has a valid token. Every API call to the backend includes the JWT token in the authorization header. And this can be best seen in our postman, where we can see that the header has the authorization as the key and the value is this auth token. The server checks this header and says, okay, I recognize you, now let me process your request. The back end is the brain of the application. So while the front end is all about making things look good, the back end is all about logic, security, and data integrity. Think of it this way. The front end is the waiter at the restaurant. The waiter takes orders and brings back food, but the waiter doesn't actually cook anything themselves. The back end is the kitchen. It receives the order or the HTTP request, does the actual work, database queries, calculations, validation, and then sends back the result. The back end runs on a server somewhere, so in this case, a Node.js runtime on port 5050. It's always listening for requests from the front end. When a request comes in, Express, which is our web framework, routes it to the right handler function. Express is like our traffic controller, so we define our routes like post, which routes to our login handler, our post, which routes to our logout, our get, which gets our agent handler, and our patch, which updates our agent handler, and so on and so forth. Each route is a pair, an HTTP method, get, post, put, delete, patch, etc., and a path. So when a request comes in, Express looks at the method and path and decides which handler to call. The handler function receives the request object, which includes the body, headers, parameters, and the response object, which we use to send data back. Inside the handler, we can query the database, do calculations, check permissions, and send a response back to the front end. But before any handler runs, requests flow through the middleware pipeline. Middleware is like the security checkpoint. Each middleware function can inspect the request, modify it, check permissions, or reject it. For example, we have this middleware, which parses the JSON body so we can access the requested body, handles CORS, and allows requests from the front end running on a different port, checks the JWT token and validates that the user is authenticated, and then routes the request to the appropriate handler. If the JWT token is missing or invalid, the authentication middleware stops the request right there and turns back a 401 unauthorized response, so the handler function never runs. This is important. The backend doesn't trust the front end. Even if the front end thinks the user is authenticated, the backend double checks the token before they process any request. So let's walk through the login endpoint step by step because this is the most important one. So the user sends a post login with email and password in the body. The server receives the request, and then here's what happens. So first thing that happens is we find the user in our database. Normally we exclude passwords from queries. For security, we don't want passwords floating around in memory, but for logins, we need the password to check it, so we explicitly include it. And then if no user is found, we return this error that says invalid email or password. Notice that we don't say the email doesn't exist because that would be a leak of information. And then our second step is we compare the passwords. This uses bcrypt to compare the password the user typed with the hashed password that we have in our database. Bcrypt is a special hashing function designed for passwords. So even if someone stole the database, they couldn't figure out the passwords because they're hashed. So we can see here in our MongoDB database that this is our email and our password. Notice this password is very confusing and complicated, but what I type in to log in is admin123. So when I created that password, it's not saved in the database because if anybody had access to this information, they would have access to the whole system, which would be a huge security risk. And as you can see up here, I attempted to create a couple of different users and just typed in the password like this, and that also did not work. It has to go through that bcrypt password hashing. So back in the code, if we see this compare password right here, this method uses bcrypt's built-in comparison, which is resistant to timing attacks. And a timing attack is when someone figures out a password by measuring how long the comparison takes. With bcrypt, the time is always the same. And if the passwords don't match, then we return this error. And then next we create our JWT token. JWT stands for JSON Web Token. It's like a tamper-proof badge. The token contains the user's ID and email encrypted with a secret key that only the server knows. This token expires after 24 hours, so after that the user has to log in again. The secret key is stored in an environment variable, so it's not hard-coded in the source code. Environment variables are configuration settings loaded in the .env file that's never committed to version control. And then the fourth step is we send the token back, which can be seen right here. So we send back a JSON response with the token and the user's basic information. The front end stores the token in local storage and then uses it for further requests. Now for all other endpoints, the front end includes the token in the request. Our authentication middleware intercepts every request and does this. It extracts the token from the header, verifies that it's valid and it's not expired, and if everything checks out, it attaches the user data to the request object. The handler can then access the requested user and know exactly who made the request. If the token is missing, invalid, or expired, the middleware sends a 401 response. The handler never runs. This is stateless authentication. We don't keep sessions on the server. The token itself proves who you are. Now let's look at the agent management endpoints. They follow a standard CRUD pattern. So we get all of our agents, This one is simple. It fetches all of the agents from the database and then sends them back. The endpoint is protected by the authentication middleware, so we know that the user is legitimate. This is our post to create a new agent. We create a new agent from the requested body, save it to MongoDB, and return the created object, which now has an ID assigned by MongoDB. The database validates the data against the schema. If someone ends up with a rating of 150 or less than 0, MongoDB will reject it because the schema says the rating must always be between 0 and 100. This is where we have our patch request to update an agent by their ID. So we find the agent by their ID, update the fields from the requested body, and then return the object. The new true option tells Mongoose to return the updated document, not the old one. And then we have our delete agent request. So we find the agent by their ID, we delete it, we return the deleted object so the front end can show a confirmation message like agent John Smith deleted. All of these operations are protected. The authentication middleware runs first. The front end must include a valid JWT token or the request is rejected. So in a real world, things fail. Networks drop, databases crash, user input is invalid. A robust backend handles all of this gracefully. The method that we use is a try-catch method. So we wrap any risky operations in this try-catch. If something fails, whether it's a database query, validation error, etc., we catch it and send it back with an error and a description. So different errors get different HTTP status codes. 400 is a bad request, 401 is unauthorized, 404 is not found, and 500 is an internal server error. The front end can read the status code and status and decide how to respond. Maybe it shows an error message or retries the request or navigates to an error page. And notice that we reference process.env.jwt secret. This is an environment variable, a configuration setting loading from a .env file. Why do we not hardcode the secret? The source code is usually shared on GitHub, for example, and you never, ever want to put secrets in your source code. Environment variables are loaded from a local file that's never committed to version control. So when the app runs on a production server, the .env file is created with real secrets. When it runs locally on a developer machines, a different .env file is used. This is standard practice for handling sensitive information, whether it be API keys, database passwords, encryption secrets, etc. Now, what is MongoDB? Most databases that you hear about are SQL databases. They're based on tables, rows, and columns, kind of like an Excel spreadsheet. But MongoDB is different. It's a NoSQL document database. Instead of tables, MongoDB has collections. Instead of rows, it has documents. A document is basically a JSON object. So an agent in MongoDB looks like this. It's just a JSON object with fields. MongoDB stores these objects in a database called Rocket Elevators Admin in a collection called agents. Why MongoDB instead of a traditional SQL database? The truth is, for this application, either would work, but MongoDB has its advantages. Number one is flexibility. If we decide later to add a phone number field to agents, we can. With SQL, you'd have to alter the table schema. With MongoDB, we just start including it in documents. And because MongoDB is flexible, we prevent garbage data using Mongoose. And you might think, can't the front end just do this validation? Sure, but you can't trust the front end. A clever hacker can bypass the front end and send bad data directly to the API. The back end is a last line of defense. And a new concept in this project is called pre-hooks. A pre-hook is a function that runs automatically before saving. So for the user modal, we have a pre-save hook that hashes passwords. So here's what actually happens is someone calls user.save. Before actually saving to MongoDB, this pre-hook runs. We generate a salt, which is random data, and then we hash the password with bcrypt. We replace the plain text password with the hash, so by the time this data reaches MongoDB, the password is already hashed. No plain text password ever exists in this database. This app is a solid foundation. It has authentication, CRUD operations, error handling, and clean architecture. The principles here scale to much larger applications. Thank you for sticking with me through this video. Thank you for watching, and I will see you on the next one.